question 15. A company makes toys for children. Figure 5 shows the design for a solid toy that looks like a piece of cheese. So the toy is modeled so that face ABC is a sect of circle with radius r and center A, and then angle BAC is 0.8 radians. So and then faces ABC and DA are congruent. So basically the top sector of circle and bottom sector of circle are exactly the same. And then edges AD, CF, and then BE are perpendicular to the faces ABC and DF. Okay, so AD, CF, and then BE are perpendicular. So then edges AD, CF, and BE have lengths h centimeter. Given that the volume of the toy is 240 centimeter cube, and they want us to show that the surface area of the toy s centimeter squared is given by this. Okay, let's set up the equation first. So S is equal to, I'm going to work out the top sector and the bottom sector of the circle. So that would be pi r squared times by 0.6 radian over 2 pi radian, and then times by 2. And then for the rectangle ADFC, that's just space times height. So r times by h. And then that'll be the same as ABED. So I will double that. So then all is left is just CBEF, the curved part. So the curved part is just like the cylinder. So if you make it flat, so that's just a rectangle. Yeah. So then you just have to work out what's the arc length, which is what's FE equal to, and then you times by the height h. So for FE, you can just do 2 pi r times by 0.8 over 2 pi, and you times by the perpendicular height h, then that'll be the area of that rectangle if you make it flat. All right, then simplify this. We have, so pi over pi cancelled, and then 2 over 2 cancelled. That'll be 0.8 r squared left. And then the second one is 2rh. And then the last one, 2 pi over 2 pi cancelled. So just 0.8 RH. And if we add them, 0.8 r squared plus 2 plus 2.8 is just 0.8 is just 2.8 RH. So that would be the final expression, but they want in terms of r, no h. So that means we need to use this volume to set up the other equation to rearrange it to cancel h. So for the volume equation, we know volume is just equal to, so this is clearly a prism. Yeah. So we can just use the area of the cross section, which is the bottom sector of the circle, times by the perpendicular height. So that will give us pi r squared times by 0.8 over 2 pi, and then times by the perpendicular height h. So that's equal to the volume, 240. So then pi over pi cancelled, 0.8 over 2 is 0.4. So 0.4 r squared h equal to 240. So that means h is equal to 240 divided by 0.4 is equal to 600. And then divided by r squared, just 600 over r squared. Okay, now we have h in terms of r. Now, as long as we replace this h in terms of r, then there'll be no h left, only r left. Then if we simplify, it should get the same. So s equal to 0.8 r squared plus 2.8 r times by h, which is 600 over r squared. So then we will have 0.8 r squared plus 2.8 times by 600 is 1,680. And then divide by r for both top and bottom, so just only r left. The square will cancel out. So it's 1680 over r, which is exactly the same as this one. Then part A. And then part B, using algebraic differentiation, part B, find the value of r for which s has a stationary point. So differentiation. So s is equal to 0.8 r squared plus 1680 r to the power negative 1. Then ds over dr is equal to 1.6 r minus 1680 r to the power negative 2. And then to find the stationary point, we just let the derivative equal to 0 and solve it. So r times by r squared for both sides. And then I will have 1.6 r cubed minus 1680 equal to 0. Because r, the part -2 times r squared just cancelled. And then make the r cubed as a subject. So I will plus 1680 for both sides and divide by 1.6 for both sides. That will be 1050. So r is equal to cube root of 1050, which is same as 10.1639. So I will round it to one decimal place, so which is 10.2 centimeter. So that would be the value of r for which s has a stationary point. And in part C, prove for further differentiation that this value of r gives a minimum surface area. So if we want to use further differentiation, so meaning we need to find the second derivative. So as long as we substitute in to get second derivative more than 0, then we shoot it. So let's differentiate again. 1.6r, so this is our ds over dr. So we need to differentiate this. So 1.6r differentiate to 1.6. And then the next one, bring down the power, negative 1680 times -2 give us positive 3360. Other part -3. So we bring down the power minus 1 the power. And now substitute in the value, which is 10.2. So we have 1.6 plus 3360 times by 10.2 to the power -3. So then that should give us a positive value. So 1.6 plus 3360 times by 10.2 to the power -3, which is 4.7662, which is more than 0. So therefore, that is a minimum.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.